Hey, first grade, for math, make sure you have a whiteboard in front of you. You don't have to do this on your whiteboard, but in a few minutes we will be doing some practice problems together, so you'll want to have it ready. As I've been doing the one-on-ones, I've just noticed a few places that we could definitely spend some time reviewing. So today's topic is fact families. Fact families. And when we're talking about fact families, the word fact is just coming from different addition problems, like addition facts. So if you've memorized your facts through 10, then you would know that 4 plus 3 equals 7. This is what we would call a fact. And in fact families, there are always 4 addition there's 2 addition and 2 subtraction equations that all use the same 3 numbers, and they all relate. So that's why we call them fact families. And if you're like, wait, fact families, what's that? Don't fret. If you're not familiar with the term, you've used fact families before to help you solve for lots of problems. So we'll dive right in. First things first, please look at my amazing whiteboard and say, ooh, ah. Wow, nice job, Mrs. F. Thanks, Mrs. F. The first thing we should look at when we're talking about fact families is this idea of part, whole. So, and for this part, y'all, you do not need to be copying this or writing anything. If you want to try, and because that's fun for you, you can always pause the video and do that, but you don't need to for this part of the video. So just looking at my little drawing here on my messy whiteboard, we have how many pink parts? 1, 2, 3, 4 is part of our part, is one part, and our other part is 1, 2, 3. This is called a part, and this is called a part. If we put those parts together, we get a whole, meaning 1. In an addition equation, we would call this an addend, this an addend, and this the sum. So every time you have an addition problem that has 2 addends, you have 2 parts that create a whole. Let me zoom out. Now, the example that I have here is the whole being 7, and I'm focusing on the equation 4 plus 3 or 3 plus 4. The switch partner is the same thanks to the commutative property of addition. It doesn't matter what the order of the addends is. You can swap them and we'll still get our answer. So the one that we are most familiar with is what we refer to as math mountains. Hold on. I need a bigger desk. Math mountains. Okay. Well, you'll see both of these on the screen, but first we're going to look at this one. And so oftentimes we'll get something that looks maybe more like this. And we'll be solving for the unknown addend or the unknown partner. And partner, right, that's long for part. So you would look at this and you would say, well, I know that whatever's at the top, the sum, is going to be the sum of these 2 below, these 2 parts below. This is the whole, and this is a part, and this is a part. So this plus whatever goes here will get me 7. And you can solve on by counting on 5, 6, 7, and we get 3. Whoops, purple for 3. Okay. That's kind of what a math mountain looks like when we normally use it. Let's look at this one. This is a little more creative. This is more this little triangle here. The same shape as the math mountain. It's a triangle, but within the triangle, we put different symbols for different operations for addition or subtraction. And you'll notice that I put a minus symbol here and a minus symbol here, but down here is a plus symbol. And that's because if I were to read across, I can read 4 plus 3 equals 7, or I can read 3 plus 4 equals 7. But you can also utilize this for your subtraction, for the subtraction equations of your fact families. So if we start with 7 and we take away 4, 7 minus 4, we will then get 3. If we start at 7 and we take away minus 3, we will get 4. That's just another way to look at it. Now, if I said to you, all right, first grade, here are your 3 numbers, write the fact families for them, this is what you would do. Here we are. This part right here, hopefully you can see that. This is what you would do. You would start by writing the 2 addends, 4 plus 3 equals 7, then the switch partners, and that's the same as saying 3 plus 4 equals 7. Now, here's the part where some of you get tripped up a little bit. It's a little tricky. Now, one of the most important things to understand about addition is when you have an addition problem, so blank plus blank equals blank, if you were to pull that problem backwards, if you were kind of to go through it from right to left, those numbers, and replace this with subtraction, and this becomes our equal sign, you'll get a true statement. And that's where a subtraction comes into our fact family. So what I've also done is I've said, okay, let me take my big number from my fact family, my 7, and I can start it here. And I know because of these 3 numbers, they all have a relationship. They're all a part of a family. I know that if I start with 7 and I take away 4, I'll end up with 3. So 7 minus 4 equals 3. I also know that if I start with 7 and I take away 3, that I'll end up with 4. And I can write 7 minus 3 equals 4. Check it out. These are all, there are no other numbers but 4, 3, and 7 on here. And these are all true statements. This is what we will call the fact family for 7, 4, and 3. Now 7 as a whole has other fact family members that it has, right? Another way to make 7 would be 5 plus 2. So 5, 2, and 7 are its own fact family. 6 plus 1, 6, 1, and 7 are its own fact families. It's just really important to see the relationship in addition and subtraction here. And the coolest part about learning this and really getting it down and understanding it is that when you get to the end of 2nd grade and beginning of 3rd, when you're doing multiplication and division, the same applies for multiplication and division. You'll find that multiplication is kind of an extension of addition, whereas division is kind of an extension of subtraction, in a way. Okay, so take one final look at my beautiful, amazing board. Wow, oh my gosh, it's so good. And now here's the fun part where you'll grab your whiteboard and we'll just do some fact families together. Fact families, by the way, don't have to just be from numbers 1 through 10, okay? They can go all the way up to infinity. Yeah, that's right. You could have a fact family of 100, 50, and 150. You can make it all work. The one thing that you have to be careful of is, let's say you go to write one of these fact families. And what if you said, oh, okay, how about 7 plus 3? What if you said, too many markers, guys, too many markers. What if you said 7 plus 3 equals 4? Yay! I used all my numbers. Is that going to be correct? No way, Jose. Because if we go to solve, let's count on from 7. 7, 8, 9, 10. Whoa, 7 plus 3 equals 10. That's because the placement of the number is wrong. The whole is only either going to be the sum for the 2 parts, or it will be the first number when you do a subtraction problem. Also to point out, where addition, the order of the number of the addends doesn't matter, but in subtraction, it sure does. If you said, oh, what about this? Let's do 3 minus 4 equals 7. I used 3 numbers. They're all the same. They're all part of the same fact family. This must be correct. And do the problem. Check yourself. 3 take away 4. Here's 3, take 4 away. 1, 2, 3. Now we're in negative numbers. 3 minus 4 does not equal 7. So you want to make sure that you double check that your placement is correct. These all are solvable. You just need to make sure that they work. Whatever's over here must equal whatever's over here. That's why we have this equal sign. Okay, rant over. Now for the fun part. I'm just gonna erase this board because it's big and I can use it. All right, let's do a couple fact families together. Again, if I'm too quick, please pause the video and that will slow me down. All right. We'll do kind of one together. How about that? And I'm not gonna keep changing up my markers because that will take us all day long and that would be so boring. Okay, I'm just gonna use black marker. I know, boring, but whatever, that's life. All right, let's try the numbers. We can just make an equation. Let's do 6 plus 5 equals, if you know your doubles, you should be able to get this pretty fast. Well, I know 5 plus 5 equals 10, but 6 is 1 more than 5, so it must be 1 more than 10, which is 11. All right. You've actually just written one of the parts of the fact families, but let's try and make the other parts. But first, let's do that fancy triangle thing. So you're going to draw a triangle. And what is our big number, our biggest number of our equation? It's 11, our sum. Our sum's going to be at the top. And then we're going to put our parts, 6 and 5, on the bottom. 6 over here or over here, doesn't matter. 5 over here. Let's put in those symbols to help us keep things in order. Minus, minus, plus. Oops. All right. Now let's finish building up our fact families. Again, four equations will be created for these fact families. 4. 4 is the magic number this time, not 3. So we have 6 plus 5 equals 11. What is the other addition problem that we can do for this fact family? Don't say 11 plus 6. Don't say 5 plus 11. The switch partners. That's right. 5 plus 6 equals 11. Okay, check, check. We did our addition problems. Now let's get on to the subtraction problems. Well, if we check our cool triangle down here, and we started our sum, we can read it. 11 minus 6 will get us 5. But we just need to make sure we write it correctly. 11 minus 6 equals 5. And if I know 11 minus 6 equals 5, I also know that 11 minus 5 equals 6. I hope you are starting to see how all these numbers are related, but depending on what symbols you're using and the placement of the numbers, they're all, they all go together. They're one family. And just to reiterate how important the relationship between addition and subtraction is, look at this bottom one we have here, 11 minus 6 equals 5. And again, we always read from left to right when we do those equations. Let's write this equation out left to right, but let's kind of go backwards from what we have. 6 is our first number. And again, if you go subtraction this way, you can go addition this way. You'll kind of be checking your work as well. So 6 minus 5. No, oh my gosh, this is F. Whew, I almost had a heart attack. Like, wait a minute, everything I've known about math is wrong. Okay, sorry, this one was subtraction. So now we're gonna turn this guy into addition and this guy into equals. So 6 plus 5 equals 11. Is that true? Yes, it is. And then just for the fun of it, okie dokie, let's take this equation and let's head backwards, but we're writing it left to right, and change this, because it was an addition problem, to subtraction, and this to equals. Okay, let's do it. 11 minus 5 equals 6. Back to where we started. Pretty cool. Okay, now I'm going to give you a triangle, and I want you to write all the fact families for what's in the triangle. On your own. Go. Well, don't go. I need to give it to you. All right. The triangle is Do some numbers like this. 15. I want you, using this triangle, and for those of you who, are a little bit more used to seeing it like this is the same as this, same thing, just a little more elaborate. I'd like you to write the 4 fact families, 2 addition, and 2 subtraction. Go ahead, do that on your whiteboard. So you'll have blank plus blank equals blank, blank plus blank equals blank. You're not writing blanks though, you're writing the numbers. I'm writing blanks so that you have time to do this. And blank minus blank equals blank, blank minus blank equals blank. If you're still working, pause the video because I'm going to fill these in. All right, you filled out your fact families. The first thing I know to do is to look at the bottom of my math mountain or my triangle here, and I see that my parts are 10 and 5 and my whole is 15. So 15 is my whole and these are just my little parts. I'm going to do them in boxes, I don't know why. So I know that my parts are always going to equal my whole, so I can actually go ahead and put my biggest number over here first. And then I know that I have 10 plus 5 will equal 15. And then I just have my switch partners, 5 plus 10 equals 15. Woo. Okay, easy part's done. Shoot. Now I have subtraction to do. Uh-oh. Oh, right. Well, again, I can't put any of my smaller numbers here to start because that's going to mess up my equations. I'm going to use my bigger number first. It's going to be 15 minus something, my whole minus a part, my whole minus a part. So 15 minus 10 will get me 5. 15 minus 5 will get me 10. Wow, I did it. Let's double check. 10 plus 5 equals 15, which would be like saying 15 minus 5 equals 10 if I go backwards. Good. 5 plus 10 equals 15. 15 minus 10 equals 5. 15 minus 10 equals 5. 5 plus 10 equals 15. 15 minus 5 equals 10. 10 plus 5 equals 15. So I don't know if you just noticed what I was doing, but I was actually just double checking my work by doing the opposite operation when I went backwards through the equation. That's how you can check your work. Okay, one more for fun. This one's going to be a little harder because I'm not going to give you the whole triangle. No way, Jose. I'll do, let's do, So I'm giving you the math mountain. So I've got 13 as the top, 13 is my whole, and one part is 9. So what I want you to do, what I want you to do, pause the video. Well, you're going to pause the video and you're going to first solve and figure out what the other part is, and then you need to write the 4 fact family equations. Go! Hopefully you paused the video and had time to work. If you didn't, pause the video now. And let's go ahead and figure this out. So first thing I have to do is figure out what's the other part in this fact family. I have my whole and I have my part, but I need the other part. So I can either do counting on from 9. I could even do 13 minus 9. Remember, I can use a fact family to get my answer. But I'm going to do counting on because I like counting on. It's easiest for me. So I have 9, 10, 11, 12, 13. How many dots did I draw? I drew 4. So now I know that I have 9 plus 4 is going to get me 13. And you know what is even a little hack you could do so you don't have to draw that big triangle? You can put the symbols right here. I think we did that in class a while ago too. Okay, let's start with addition. Classic. Addition for fact families is going to be part, whole. So 9 plus 4 equals 13. Switch. 4 plus 9 equals 13. Thanks, commutative property. Okay, now I'm on for my subtraction. Remember, subtraction is always going to start with the whole in the fact families. So 13, I'm just gonna do this. It's gonna make my life easier. So I know, okay, both are gonna start with 13. And in my first one, am I gonna subtract 7? No, 7's not in here anywhere. Am I gonna subtract 5? No, 5's not in here anywhere. What are my parts? Oh, my parts are 9 and 4. I'm working with those specifically, so make sure you remember. Let's start with 9. So 13 minus 9, well, I know that will get me 4 because it's the other member of this family. And now I'm gonna do 13 minus 9 again. No, you're just doubling up. Don't write the same one. Make sure that you've changed it. Oh gosh, okay. 13 minus the other part being 4, will get me 9. Ooh. Man, it's hot in this room. Probably because I'm wearing this big sweater. Okay, great. I hope that helped with the fact families. And if some of you were like, I already knew this, Mrs. F, well, great. This is great practice for you. But I hope that for some of you who were kind of forgetting or a little confused that this helped you. If you're still confused, there is a lovely Khan Academy video that I linked underneath this on the daily website to just have Sal explain it because, you know, he's so good at this stuff because he is kind of an amazing math guy. But great, good work, and have a great day. Bye.